Welcome everyone to the 2022 Vision Spectra Conference. Thank you all so much for joining us for this keynote session where you will hear from Andrew Ng, the CEO and founder of Landing AI, which builds and deploys AI solutions. Andrew, formerly the head of Google Brain, co-founded Coursera, an online learning platform with more than 82 million learners. In this presentation, Andrew leverages small sets of data to solve real-world applications with deep learning. If you have any questions or comments, you can type them right into the conference chat box on your screen. And if you missed part of today's session, you can always come back later and watch it on demand. If you have any technical issues throughout the event, please log out and back in to rejoin the session. Lastly, Andrew, thank you so much for taking the time to present here at the 2022 Vision Spectra Conference.
Cool. Thanks for having me, Jacob. And hi, everyone. It's good to see you here online. So for the last few years, I've been working on software that makes computer vision and machine vision super easy. Hope to share with you some of the lessons I've learned about the shift toward data-centric AI, which is a new set of tools that will let you build and deploy successful computer vision systems and machine vision systems, even using relatively small amounts of data like we often have in automated inspection applications. So hope to chat to you today about the shift from big data to good data and the shift to data-centric AI. You might have seen studies like this estimating that AI will create 13 trillion US dollars worth of value per year with impact on all sorts of industries. But candidly, from where I'm sitting, I think AI has had a large impact on the consumer software internet industry, companies like Google, Microsoft, and so on. But in other industries, including specifically industrial automation, I think this impact is still quite early, although growing rapidly. A recent Google Cloud report estimated that 2 out of 3 manufacturers are using AI or starting to use AI. On the flip side, I think that many companies in industrial automation are still in an early part of this journey. I think the potential is there. One of the top 5 areas of AI in manufacturing is quality inspection, such as defect detection, partial defect classification, object localization, assembly verification, or anomaly detection. And I think there is this hope or promise increasingly realized that AI will help us to simplify our workflow, deal with variability, and handle subjectivity. In terms of simplifying workflow, what I'm seeing is that there have been a lot of machine vision applications that for many years have been done successfully with rule-based machine vision or with discrete analytics. But I found many applications where even though you can write a handful of rules or write several pages of rules, the workflow of the vision engineer becomes simpler if you adopt a deep learning approach, so that rather than needing hours or days or weeks of work to come up with that set of rules, you can simply show an AI system a set of images, label a set of images, and have the AI system figure out for itself what are the rules or what are the appropriate ways to determine if something is defective or not, or the appropriate way to detect something or not. And of course, in more variable settings or in subjective defect detection, I think that AI deep learning based approaches are proving to be extremely effective and can handle cases that older methods were not able to. Now, I think we all seen that AI has huge promise and will probably over the next several years transform all of us, the way all of us do automated inspection. But barriers still remain in AI adoption, which is why AI adoption in industrial automation is still in a very early phase. I've actually looked at AI applications in many different industries, and I want to share with you what I think are the 2 biggest barriers to AI adoption, focusing on manufacturing as the prime example, because that's what I've been working on, that's what I think many of you care about. But as a pattern that is actually true more broadly across many different industries as well, and not just manufacturing. I think the first major barrier is small data sets. When I was working for a large internet company, I once built a face recognition system using 350 million images. But in industrial automation, hardly any of us have 350 million images of a defect we want to detect. I gave a talk, I think it was actually another, some time back, where I asked the audience, how many images do you typically have of each defect type you want to detect? And this was the answer. Not surprisingly, we don't make that many defective parts, fortunately. And so there are a lot of defect types where we have 50 or fewer images that we still have to detect reliably. And so technology that I and others had built for 100 million data points just doesn't work for other industries. AI had grown up in consumer software internet, where a single company may have hundreds of millions or even a billion plus users, and that's a single giant data set you can apply AI to. But in manufacturing and many other industries, these giant data sets just don't exist. So that's why it's important, landing AI, other teams, we've been pioneering techniques that allows us to get AI and deep learning systems to work, even with modest data sets, like dozens of images, or maybe hundreds, but often dozens of images. Let me share with you what I think is a second major barrier to more widespread AI adoption is the customization of the long tail problem. Um, if you take all current and potential AI projects in the world and sort them in decreasing order of value, you get a curve that maybe looks like this. Maybe the single most valuable AI system in the world is some system that decides what ads to show people, one of the large ad platforms. Maybe the second most valuable AI system is some AI that improves web search quality. Maybe the third most is an AI system that makes better product recommendations for online shopping website. So the AI world had for many years focused on building systems that where you can build a single monolithic giant AI system that serves hundreds of millions or even more than a billion users and generates massive economics. But once we go to other industries, such as manufacturing, that recipe for AI adoption simply does not work. In industrial automation, we may have a plant that is a pharmaceutical plant that is inspecting pills. Maybe a different plant is making sheets of steel and needs to inspect that, and a different plant is making semiconductor wafers and needs to inspect semiconductor wafers. Each of these different manufacturers needs a custom AI system because the pictures of all of these things are very different. So every application, every product that's manufactured needs a custom AI system. But how do we get these tens of thousands of very valuable projects across manufacturing built without, say, someone like me trying to hire tens of thousands of machine learning engineers to try to do these projects one at a time? I think the only recipe, the only path forward is to build vertical platforms that enable the end customer to build the custom AI system that you need in order to inspect all of these different diverse applications. I think that the AI world has figured out how to solve problems in the head of the curve, where a single AI system may generate $1 billion worth of value, say. But in the long tail of this curve, what I'm seeing is that there are lots of hundreds of thousands or $1 to $5 million projects that no one that hardly anyone is yet effectively working on because the economics of building a cutting edge AI system for these hundreds of thousands of dollars or several $1 million types of applications has not worked out so far. But with a new paradigm of AI called data-centric AI, the ability of lots of teams to build and successfully deploy these AI systems is becoming more widely available. It's becoming much more widespread and much more widely available. But what is data-centric AI? Over the last many years, most machine learning or AI development has used what's called the conventional model-centric approach, in which an AI system requires both software or code that implements some AI algorithm, or sometimes we call it an AI model, as well as data for the AI system to look at and to learn from. And so in the AI field, for the last few decades, the conventional paradigm for development was that researchers would find the data set and hold the data fix while they work on the code. Thanks to this paradigm of research development, I find that for a lot of the AI algorithms and AI models had advanced rapidly over the last several decades. And I find for a lot of applications, the code is basically a solved problem. You still need an experienced AI team that can help you choose a good model, or rather you need someone, you do need to make sure that you have a good cutting edge implementation of an AI system with a very good choice of parameters. But so long as you have a good enough AI model, then I found for many applications, it's actually more fruitful to take what's called a data-centric approach, in which you can let someone provide to you a cutting-edge AI model and instead focus on working on the data. And I think that this data-centric approach, in which you get a good implementation of an AI model and focus on entering the data, is key to unlocking the value of AI in manufacturing and industrial automation. Because I think for many teams in manufacturing, if you ask your IT personnel or ask your machine learning engineers to spend all their time doing research on AI algorithms, yeah, you could do that, but that's a slow process. But if you instead ask your teams, ask your vision engineers, ask your inspectors to focus on engineering the data, on labeling data to express the domain knowledge about what is the defect, on looking the data to help clarify exactly what is the defect and what is not, um, that empowers a much broader group of people, including specifically subject matter experts and inspectors, to contribute to the data that helps the AI system get much better. And so this empowers many more people to use these tools, and is, I think, the key to democratizing AI, because many people will find it accessible to engineer the data, whereas engineering the code is just much harder for most people, even me, to work on. And because in AI, good teams implementing the code can get very good models tuned and implemented. We found that so long as you have a good piece of code, data-centric AI actually often yields better results. There have been interesting results in computing that show that if your data just has a 12% error, so 12% of the labels are mislabeled or noisy or something, if just a little bit of the data is noisy, you may end up needing twice as much data in order to achieve a certain level of accuracy on a task. And that's why by having tools to help systematically engineer and improve and clean up the data, that turns out often to be a significantly more efficient way, lower time, lower cost, to develop an AI system that you can put into production. So the time to value is much lower when you have a data-centric set of tools that helps you get the data really good for your application. So data-centric AI is the discipline of systematically engineering the data used to build an AI system. And over the last several years, my team at Landing AI has been building tools to help make data-centric AI more efficient and more systematic. What I hope to do is share with you some of the lessons that my team and I have learned, really pushing forward data-centric AI over the last several years, in the hope that this will also help you as you think about how to use deep learning based computer vision or machine vision systems for your own applications. So I've talked a few times about the importance of having good data, but what does that mean? So data-centric AI focuses on making sure you have good data rather than only that you have big data, right? Rather than just having a massive data set, let's make sure you have a good data set, even if it's not a giant data set. So what is a good data set? I'm going to list 3 key traits and then dive into the details a little bit. First is the data set should have consistent and accurate labels. Second is it should have representative and high quality inputs. And third is the data should reflect post-deployment changes. So after you deploy it, if something changes, you need a way to capture the data and flow it back into the system. So let me dive a little bit more into details of this. Consistent and accurate labels. It turns out that for many applications, we have had skilled inspectors inspecting, pharmaceutical pills or sheets of steel or semiconductor wafers, highly skilled, highly hardworking, well-meaning, smart inspectors inspecting various things for years. And I've walked in many manufacturing plants where there were 2 or 3 great inspectors that have been making inspections for years, but unknown to them, they've actually been not agreeing with each other for years. So here's an example of the sorts of inconsistencies I've seen in many manufacturing settings. Given a pharmaceutical pill like this, it's not at all uncommon for one laborer to say, oh, I'm going to tell the AI system this is a chip. Looks like a chip. Different laborer says, oh, I'm going to tell the AI system this is a scratch. It also looks like a scratch. Is labor 1 or labor 2 right? I honestly don't know. Both of them seem, quite plausible and smart. But it turns out that inconsistencies like these, um, it actually leads to inconsistencies in the inspection standard, and so arguably hurts quality. And if you're building an AI system, this makes the data very confusing to the AI system, because the AI system will look at this data and go, is it a chip or is it a scratch? And be confused and not be able to detect either the chip or scratch or whatever this is. And it turns out that having tools to detect these inconsistencies and resolve them is a key tenet, is a key pillar of data-centric AI that'll help you to efficiently get better results for your application. Many other examples of inconsistencies. Second is a bounding box size. So we often ask labelers to draw a rectangle around the discoloration, or use a rectangle to show us where the discoloration is. One labeler will label like that, where the most intense discoloration is. Second labeler will label like that, and various things in between. I don't think either labeler is doing a bad job. They're both doing the best, smart, well-meaning, but these inconsistencies are getting confusing to the AI system. Or number bounding boxes, very common. One labeler will label like that, and the second labeler will label like that. So what I found in terms of building tools for AI systems for deep learning based inspection systems to solve these machine vision applications is important to try to provide a label book or a defect book, digitally, ideally, that allows different inspectors to discuss and align on a definition of what exactly is a defect. I want to show you a demo of feature that feels basic, but it turns out that with the different manufacturing teams I've worked with, time spent in the definition of defects turns out to be some of the highest ROI time spent, in which we encourage teams to spend the time to carefully define what is the discoloration, what is the scratch, what is the chip, and write up clear definitions, and then also to have teams discuss and debate labeling instructions so that multiple labelers can drive toward consistency in terms of how you specify what is a defect as well as how you label that defect. So even though this seems like a basic feature, this defect book or this label book, I found that for many teams that time spent agreeing on the definitions of a defect and also having tools to help labelers or help inspectors agree on that definition of what is a defect, that turns out to be a key step in driving an AI system to have a consistent set of labels that then helps you automate this inspection task to much higher levels of accuracy. Let me switch back. Sorry, I'm not very good at. Let me switch back to the slides. All right, cool. Okay. Now, one other thing you may hear from AI teams is, wouldn't it be nice to have more data? Wouldn't it be nice to have improved data? It turns out that when you have a data set like this, there are just lots of ideas for how to improve the data set. You can look at the consistency of the way different defects are defined, but should you work on the consistency of the chip defect, or the discoloration defect, or the scratch defect? Or you could try to collect more data of some of these defects, or maybe collect more data of everything. But improving the data seems like a never-ending journey with just so many different things to work on. It turns out that if you have tools that can tell you your inspection system is doing just fine on certain types of defects, but that subset, or in AI we call it a slice, but it just means subset of the data, that's where some improvement will help you the most, then that helps you be much more efficient in terms of allocation of resources, so that when you're looking at a data set like this, gives you a clearer direction to decide, of all of these images, that subset, that small subset, is where I should focus my attention rather than the rest of that data. So sometimes we call these error analysis tools, but if given all this data, there's a way to find out that the system is doing fine on most of this, except say that subset of the data, the chip defect. If there's a way to focus your attention to say the labels are too inconsistent just on this one defect, then that helps you be much clearer and much more efficient in terms of the use of your time to decide maybe we should find a way to either get more images of the chip defect or improve labor consistency on the chip defect. So I want to share with you one of the advanced tools that I'm excited about that has helped many teams become much more efficient in the use of their time in terms of where to label more images and try to get more consistent labels. So share with you an agreement-based labeling feature that helps teams collaborate and also align on where to focus their attention. So this is a set of images in which we had asked three labelers, Michael, me, Andrew, and Nicole, to label. And I have sorted these images in decreasing order of agreement score. Now, you have heard some AI teams say, why don't we get 3 people or 7 people or tons of people to label an image and then get them to vote and just take the average. But that's not what I advocate for applications where you have, where you don't have hundreds of millions of images. What I advocate instead is to use what's called an agreement-based labeling tool, where for this image, the agreement score is 0.95. And so Michael drew that bounding box. Me, Andrew, drew a very similar one, and Nicole drew a very similar one. So Michael, Nicole, and I are in high agreement. Here's another one where, our agreement is actually pretty high. But if I sort this in decreasing order of agreement score, then let's look at the image with the lowest agreement score. For this example, Michael drew a single bounding box around these two chip defects. I drew 2 bounding boxes around the 2 individual chip defects, and Nicole drew a single bounding box on just one of the chip defects. It turns out for a lot of AI applications, there will be inconsistencies like these buried in a large data set. You may have dozens or sometimes hundreds or sometimes even more images, but if a subset of the defects, the subset of the labels are inconsistent, is surprisingly difficult for a team to figure out where the inconsistency is and resolve it so that the team can move forward. Usually images are also labeled only by one person, not by 3, and that makes spotting inconsistencies even harder. So an agreement-based labeling tool is one of the tools that allows teams to coordinate and collaborate and work together. And by asking different people to label the same image, this tool allows you to quickly hone in of all the different defects. Chip defect is the one defect where there's inconsistency, and that's where we should focus attention in order to improve the data and help the AI system get better to get the level of performance that you want. So again, this is one of the tools that I've seen many teams use to very rapidly improve performance in a way that just wasn't possible, without a similar tool. Let's switch back to my slides. All right, cool. So finally, I think it's important as well for the data you have to reflect post-deployment changes. This is what I think of as a full life cycle of a machine learning project. We have to scope the project, so decide what to do, collect data, so take images, label images, train a model. And in the machine learning development process, when you train a model, you often find that the model isn't at the level of performance you want yet, and you would go back and improve the data, train the model, and iterate a bunch of times until the model works to your satisfaction. After that, you would deploy it in production, often at the edge. And even after you deploy in production, you find that sometimes the data changes. Something about the line changes, material changes, or something changes, causing you to need to take data from the deployed instance. From landing edge would be what landing AI, the software that landing AI uses. But to take the data from the edge and to flow it back to your training system to maintain and update the system, but to close the loop. So the data from deployment, if you have a connected edge device, network connected edge device, allows you to monitor what's going on at the edge, collect data back from the edge device, update the model, and then also to push updated models back to the edge. So you can continually improve the AI system that you have running at the edge. This is a screenshot of the deployment dashboard that Landing AI uses. This is called Landing Edge, and it allows you to, from a centralized dashboard, if you have a connected edge devices, and if you don't, you have to go to the edge device yourself. But if a connected edge device, it allows you to flow the data back from the edge to continually update the AI system or to continually monitor the performance at the edge. So before I wrap up, I want to just touch on a few, just a couple key concepts, which is throughout this presentation, the recurring theme has been that I think data-centric AI democratizes AI and makes it accessible to everyone. Because often I've seen that instead of trying to get an AI expert to do all the work by themselves, um, when the workflow is about entering the data, it makes it much easier for multiple experts, subject matter experts, quality managers, labelers, vision engineers, various solution developers to collaborate, discuss and debate the data, make the data better together. And that results in the AI system then actually more quickly getting to the performance that you need, as well as after deployment, maintaining a high level of performance. And there's one other lesson I've learned working with many industrial automation companies deploying data-centric oriented AI systems, which is that AI development, machine learning development, by its nature, tends to be a iterative process where you train a model, examine the results, and then based on how it's doing, if it's not yet doing as well as you hope, you often want to go back to update the model, or in rare update the data, excuse me, or in rare cases update the model. But this iterative workflow of AI is to train a model, examine the results, see where it's not yet doing as well as you want, and then update the data, be it relabel some images or give it more images, and that allows you to retrain a model that then gets better and better. And what that means is that if you have an easy to use tool that lets you iterate through this process quickly, then that allows your teams to be very efficient, or at least to be much more efficient in driving improvements in the progress of your machine vision or your computer vision system. So one of the things I've focused on and been excited about is building tools that makes computer vision super easy, as well as fast to use and train. So let me show you a quick demo. This is an application in which there is a food and we wish to detect if there's foreign particles in the food. So I've labeled most of the images except for this one image. So, for most of these images, I've labeled the screws, the foreign particles. And let me just show you what labeling looks like. So I'm gonna just draw a rectangle around the screw. It's actually, I didn't draw it perfectly, but it's pretty good enough. This is a live demo, so actually you never know what's gonna happen. And after labeling the data, you just have to click the train button to start an AI model training. And so while it's doing that, just to show you, I had previously uploaded 27 images with a serial and some of these screws, and I had labeled all but one of the images. It took me just a few seconds to label one of the images. And by uploading data to this Landing Lens platform and clicking train, this actually kicks off a training job that allows the AI system to examine all of these images and try to determine, what is this defect or what is this foreign object that you wanted to look for in the food. What you saw me do was I just labeled that one image and it's fed into the training, and I didn't label it perfectly. So I honestly never know. Learning out, I actually am not quite sure what exactly is going to happen. So this is actually a real demo where the results are, not guaranteed. We'll give it a few more seconds to train. But one thing I found is that by making computer vision and machine vision super easy, all you need to do is upload images to the software platform and then draw, say, rectangles or provide other types of labels to the AI system, and then maybe click a button to have it train, and that's how long it took. It took like just a few minutes, a minute or two to train the model, and then we can now look at the predictions, right? And so it actually looks like it's finding the screws pretty consistently. Let me actually, the AI system actually only looks at some of the images when training. So this is called a dev set. These are images that the AI system did not look at when it was trying to learn. And from this smallish data set of just, I think it was 27 images, it learned to find that screw, right? The dashed line is the predictions, and that one, and that one, and so on. And so with a very quick workflow, using, I guess, those 27 images, which you can label in just a few minutes, you can actually build a cutting edge deep learning based AI computer vision system in just minutes. And that turns out to be important because when you can, when by making building the system easy, it allows teams to get going very quickly. It allows teams to build the first model and iterate through this workflow quickly and drive improvements in the system. In fact, just a few weeks ago, my team, Landing AI, we were at the Automate conference in Detroit, and I was actually I was delighted that many attendees at the Automate show were able to come up, and they were able to use the Landing Lens tool to train a cutting edge deep learning based system in just minutes. So for quite a lot of attendees, they told me they had never trained a cutting edge deep learning system before in their life, but with tools, with the software tools that we provide, that makes computer vision super easy. Many attendees here, right at that Automate trade show in Detroit, trained a deep, cutting-edge, advanced deep learning system for the first time in their lives, and did so in just minutes because of the software tools that make it super easy. And what we've been seeing at Landing AI is that this paradigm of AI development, data-centric AI, in which we provide tools to help you engineer the data, this often increases inspection accuracy and does so quickly, and so reduces time to value, reduces development time. One case study, we're working with steel manufacturing plant that internally had achieved 76.2% accuracy, and they wanted 90% accuracy. A few large AI teams, including one from a very large AI company, leading global AI, global, very well-known AI company, went in and had the teams look at the fixed data set and take a model-centric approach to try to work on the model. But after multiple teams worked on this for months, those other teams made essentially no improvement. Landing AI went in with our data-centric tools, and in just, was it 2 or 3 weeks, we were able to support them, to help them, not us, and this is key, they were able to improve the quality of the data so that in just weeks, they got a much better machine learning result. And this example is actually quite illustrative of many machine vision applications I've seen once a team shifts toward a data-centric approach and has the appropriate tools to make data-centric oriented computer vision development super easy. Just to wrap up, I think that we all have heard or aware of the promise of successful implementations of automated inspection. We're seeing it rapidly grow in quality control, in which you increase defect detection accuracy and improve yields. We're seeing many teams start to use deep learning to increase productivity and also to improve quality and reduce costs. I think all of these benefits are there. And tools to make it super easy to implement the data-centric AI approach and build cutting-edge systems is, I think, the key to unlocking a lot of this value for many organizations. To summarize, data-centric AI is a discipline of systematic engineering the data needed to build an AI system. And I think this is the key, at least a key, to addressing the small data problem so we can get AI systems to work with just dozens of images of each defect. Hopefully we have more data, but sometimes you only have dozens of images. We've got to make it work with that data set. And it also makes the customization or the long tail problem feasible so that instead of just trying to build one AI system and hope that solves all your problems, you have the capability to empower many people to build many different custom AI systems that you can deploy across many different lines. Just to share with you where I think um, data-centric AI is. In the AI world, I remember when 15 years ago, with the rise of deep learning, initially there was just a small handful of experts that could do it intuitively. A bunch of us were implementing neural networks in C++. It worked, but it was very error prone. Eventually, with the rise of new technologies, the principles become more widespread. We're publishing papers on deep learning, and so many more people were able to implement neural networks, deep learning, in C++. So more widespread, but still error prone. And then eventually, there were software tools like TensorFlow and PyTorch that made the application of deep learning more systematic. So this is a common journey of the rise of a new technology. In the case of data-centric AI, which I think will unlock lots of value for you and for many other teams, I think for many years we have been in that phase where there have been, experienced AI people that have been doing it intuitively. Um, I think over the past year and a bit, we've certainly now are firmly in this phase of the principles are becoming more widespread and more teams are starting to apply it. But I think to democratize access and make this really available, tools to make the application of these ideas systematic will be key to making this reliably doable by many organizations. So just to wrap up, I think AI will reach its full potential only when it's accessible to everyone. For many years, maybe small numbers of decades, I've been excited about working through education or tools to democratize access to AI. And I think for this next era of AI, data-centric AI and tools, specifically to empower lots of teams to engineer the data collaboratively, will be key to democratizing access to AI. And I hope that these ideas will help you and many of your colleagues and friends will help you build and deploy more successful AI systems and enjoy much lower time to value. Thank you very much.
Andrew, thank you so much for taking the time to present on data-centric AI and its ability to solve real-world applications. We do have time for a couple questions here, and I would like to remind everyone in the audience, if you haven't already, you can type your questions and your comments into the chat box, and if it isn't answered, you'll be reached via email at a later date. So Andrew, when we start discussing data-centric AI, I mean, I guess where's the jumping off point? How do you even begin implementing that process?
Um, yeah, I would say if you have a computer vision or machine vision application, get in touch. I think Landing AI has the best, I think has very advanced tools for data-centric AI for computer vision. And if you reach out and share with us what you're working on, we may be able to help provide tools to help you be successful doing this. To start building an application, you do need some images. So collect some images, but often dozens of images is enough to get started. If you have hundreds of thousands of images, great. If you have that, let's use that. But often just having tens or 10, 20 or low dozens of images, often that's enough to start to get a sense and train an initial model and get a sense of what will be the next fruitful step to go from there.
What for that is what is the most obvious barriers that different organizations or companies might start to face when the adoption process of AI really begins? And are there kind of simple, I shouldn't even say simple, but is there another process to overcome those challenges?
You know, I think that uh, so I've been working for a few years. Landing has been working on software to make computer vision super easy. Um, Despite that, I think that there is a little bit of training and education that's needed for different teams to learn enough about AI, learn enough about how to engineer the data to take advantage of these new technologies to deploy things. I do think that it'll be a long journey. I don't know. I would love if, as more teams adopt this, the biggest problem you have is sort of, I don't know, if manufacturers are doing so well, you don't know what to do with all this money you're making. That whole real problem that many of you are watching this video will have someday.
I'm gonna make you break out your crystal ball for a quick second here. You were reflecting on what, the data-centric AI, what you were working on, 10, 15 years ago. What kind of impact will AI have on automation and manufacturing maybe in the next 5 or 10 years, would you say?
I think it's coming. I feel like going to different shows over the last year, it seems that every few months, the momentum behind AI feels more solid. I think it's very clearly going to get there. I feel like a few years ago when I started learning AI, the skepticism about the relevance of AI to manufacturing was much higher, and I was
Mhm.
worried, boy, am I doing the wrong thing? And maybe not, maybe I'm missing something. But now when I walk around the, AFE Forum, Automate trade show, the momentum and conviction behind AI is very strong. And so I think that it's just a matter of, it's no longer a question of whether we'll get there. It's just a question of who can get there faster and who is going to be more skilled at exploiting this new generation of tools to drive this next wave of automation that create a lot of value.
Awesome. Hey, thank you. We have time for one more question here. And us with the Vision Spectre conference, our goal is to, look at the machine vision industry and kind of look at what's next. What is everyone working on? You mentioned automate. Is there anything that made you kind of do like a double take? You had to kind of look at it a couple times because you're a little surprised to see some emerging technologies?
Oh boy, thanks for asking that. There's so much going on in Automate. Maybe one thing I was really delighted by was at the Automate show, we're asking lots of people, have you ever trained a cutting edge deep learning system before in your life? Most people said no.
Hmm.
And we asked them, do you want to? And almost everyone we asked said, yeah, I could do it in just a few minutes. And then they did. And it was really nice to have lots of people. I've been training machine learning models for a long time, right? I've been, doing this myself for a long time. But what excites me is not whether I can train a machine learning model. What excites me is whether we can empower someone else, that maybe has never trained a cutting edge deep learning model before, to train a cutting edge deep learning model and to do so for the first time in minutes. Because then I feel like we can put these tools into the hands of a lot more people and empower a lot of people, not me and not my engineers, but empower
Hmm.
really a lot of people in the manufacturing audience, in the manufacturing industry to do this, to do these things themselves. And I think that's key to unlocking a lot of value.
Awesome. Hey, Andrew, thank you so much for taking a couple extra minutes here to answer some questions. I'd like to remind everyone in the audience that this session is hosted by us at Photonics Media, and we hope everyone out there is enjoying the 2022 Vision Spectre Conference. Lastly, Andrew Ng, thank you again so much for being a keynote speaker and presenting data-centric AI using small sets of data to solve real-world applications with deep learning.
Thanks so much for having me and landing AI here, Jacob.